I got my own pretty. That's gonna be not bad at all. I'm gonna pull the lights up a little bit. Hello. Yes. So can you guys see that okay? The screen okay? Screen's okay? Ish. Okay, let's see if I can get some more light on. Hang on.
Oh, it's good.
You really need to clean your optics there for your...
The camera?
No, your calculator.
The screen.
Yes, the screen, the whole thing.
Looks like you got lunch
Just
on
looks
it.
like it has
It
crusties.
probably does have lunch on it. Occasionally dinner. Well, it just sits in my bag when I'm not using it, and then my mom sent me Scotty in the mail. So is that a little better with the lighting? I moved the lights in closer. See the cursor blinking up there? And I think once we start actually pushing buttons, it'll become clear. So I want to re-answer Sean's question from before, or somebody asked me the X bar, how to calculate, and I mentioned you just do a weighted average, like we did in 243. Now, of course, you don't remember that. That was like 6 months ago. Like, yeah, that was great. That was like halfway through last term, which was 3 months before that. So I want to make sure you remember how to do a weighted average, TI-wise. Say that again?
That was 6 months ago?
I don't know, I'm making numbers up now. Four and a half. Probably when you learned is probably 4.5 months ago or 5 months ago. I mean, it's been a while. So, if you want to know how to do them by hand, all my 243 notes are still online. You can always go back to there. I got videos that walk you through that manually as well as technologically. But to do it in your TI, which I think we should do, press your stat button. Get to your editor. Edit.
This is for a weighted average?
This is for a weighted average. Yes, ma'am. It'll also work for any, excuse me, larynx. It'll also work for any average, but you have to do it this way for a weighted average. And if you're not using a TI, this is totally fine. You could do this with other technology. It's just that most of you are sitting with one of these in front of you. If you want to hang with a student that's got one, that's fine too. I've got a bunch of crap in mine. I'm going to clear. Do you guys have stuff in yours too? You might.
Yeah.
I'm going to clear it out by using the clear button. Put your blinker on top of each list and press clear. So on top of, you only need 2 lists, L1 and L2.
So you need to clear, do we need to clear them all?
You don't have, there's actually a button you can use to clear all. I can show that to you too if you want to see that. I'm going to clear all, I don't know why I've got so much stuff in mine. You only need 2. You need 2 because you have to put the X column and the F column in. You can clear them all, not a problem. But you only really need 2 for this. And then once you got them cleared, put in the data. The data in L1, the frequencies in L2. So that was 0, 1, 2, 3, 4, 5, and 3, 15, 41, and then 31, 15, 3.
And now,
Mm-hmm.
I remember last time I had put in my thing backwards. I think I had in frequency and L1 in my data.
Yeah, which is not the end of the world.
And it made it backwards, but then you have to make sure you set it to where...
Yes. So if you put it in backwards, we can fix this right here. Once your data's in, it's just a matter of running what's called 1var statistics or 1var stats. So press your stat button again. Over to calculate. 1var stats. Now what you don't want to do right now is press enter. Because if you do, it's only going to average, do you remember? It's only going to average list 1. It's not going to average list 1 with list 2 as the weights. So you have to put in L1, comma L2,
Or
L2,
L2.
comma L1, exactly. In our case, L1, comma L2. Data, comma frequencies. So L1, comma L2. Everybody knows where the comma button is. Maybe if you don't, it's right above the number 7. And it should look like that. If anybody else pressed 1var stats, did it look different on your screen than mine did? Can I fix it real quick? Dave, if you don't mind. Oh, you got it's the 84. Okay, good. I can make this work. Yeah, they have a bug that they didn't fix. So what I can do is I can change
Where we have right now, we're just on L1. Where's the L1?
Now, when you go to stat,
So you
have 1var. Yeah. And L1, L2, remember how to get L1, L2? This, I can turn this off. Yeah, that's why I asked, because they've tried to fix a problem that didn't exist, kind of like Microsoft does all the time, and they ended up making it worse. So, you guys solid? Yeah. So, there is an 84 issue, potentially, depending on how old your 84 is. Hopefully we'll fix them as we see them. Everybody getting L1 and L2? Second 1, second 2? Good. And all this stuff, like I said, I've got tutorials in the 243 page. I can point you to them if you need help. Just send me an email. I'll shoot them off to you. Happily. Happily. Press enter! Ha! Yeah, don't forget your data. Otherwise it's gonna get pissed at you.
It's been a while.
It's okay. I know it has. That's why we're doing it again. I know it has. A lot of information here. A lot of information. Some of it we already knew. We knew that we did 108 trials. We knew that because we added it up earlier. We didn't know much of everything else, though. We asked, what's the average? And we said, it's about 2.5. Well, obviously, it's a little less than 2.5 because the bar on 2 is bigger than the bar on 3. And these match perfectly. So there's a little more weight on this side than on this side, which means the average has to go to balance that weight. Remember the idea of a balanced average from 243 when you put your finger to balance the curve? It wouldn't be directly in the middle of our sample curve. It can't be. It has to be a little bit to where the weight is. So it's about 2.4, 2.45. A little bit south of 2.5. But damn close, yeah? Damn close to that 2.5, yeah. Sean asked a great question about standard deviation. And I mentioned we could calculate standard deviation. If we needed to, we could kind of go up there and let's put the camera over there real quick. On our graph, since it's roughly a bell curve, you could take your hands like this and say, wouldn't that be about 95% of the curve between my hands? That would leave off the extreme tails. And that's actually pretty damn close, because this is just about 100. And this is just about 5. So we've got roughly 95% between. Hopefully that makes sense. And if you think about the level of number that is covered by that, 2 down, 2 up, that roughly corresponds to the standard deviation is about 1. 2 times 1 is about 2. And this is all ish, right? We're not using a whole lot of precision. We're using more big picture ideas here. So that's the beauty of a bell curve. It's really easy to see that standard deviation. And there's your symbols again. As far as S, sample standard deviation, and, well, you can ignore that one. That's BS. BS. S and BS.
So the SX is the standard deviation?
Of the sample. So of all your 108 sets of 5, your standard deviation was roughly 1 red card standard deviation that you saw. You saw on average 2.5. Don't sweat this one too much, Allie, because we have to mess with that at 244 anyway. It's not going to stay that way. It's going to be messed with. And this other stuff is not super important either. The second one down to 265 means you guys in total saw 265 red cards in all the trials that you did. 265 red cards out of 108 times 5 cards dealt. Does that kind of make sense? Yeah. You can ignore that. It's not hugely important for this class either. Yeah. Yeah, no.
Pressure. And the standard deviation is how far from the left or right it is from the average.
Yep.
Right?
On average, how far the data points are from that average. Yeah, that's exact. Good connection from 243. Very, very good. Very, very good. Good so far? That make sense? Yeah. So there's the neat connections between 240. This is all 243. It's all descriptive. Now we're gonna take the next step. Now we're gonna take the next step, huh? So my East Coaster again. We're gonna take that next step to be able to say, okay, suppose you didn't know anything about that deck other than the results you were getting out of it. So we knew that half the deck was black, right? And half the deck was red. Because it was fair, because I told you it was a fair deck. Suppose it was more like my experiment, where you don't know what the deck is. You're being dealt a card, and all you're getting is the picture. What would you say was the average of the deck in your hands? Would you say 2.453703704? That's mu? Because it has a mu, correct? That deck has a mu, yeah. You don't know what it is. The samples that you drew from the deck have an average, an X bar average of 2.453703704. So would you go to Gallup and say, I got it! The average you're looking for is 2 point, whatever that is. Would you say that? Should you say that? Let's say it a different way. That's an easier question to answer, right? Should you say with that kind of precision what the average of the population is? Because it's the average of your sample. Is the average of your sample the same as the average of your population? No. Exactly the same. No. Should it be close to the average of your population?
Yes.
Yes. Assuming we did it correctly, which I watched your guys shuffling, I'm envious. Yes. How do you adjust for the fact that it's not the same? How do you adjust for the fact it's off now? How do you adjust for the fact that 2.45 blah 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 is not exactly the population's average? How do you adjust for it?
Is the standard deviation?
Yes.
Plus or minus?
But the inferential standard deviation is called a margin of error, and that's what 244 is all about, is how to measure that margin of error. Thank you, Aaron. Yes, it is. That's why I said Allie with S up there and Sean with S up there. We got to mess with it anyway, because we have to make it inferential. Yes, and that's what this class is all about, is measuring that error around your sample average. That's all we're going to do for 10 weeks. 9 weeks after this day is over. Actually, I lied. 8 weeks after this because we're short a week. That's what I love about this course. It's the same thing in slightly different tweaks the entire time. That's wonderful. It's wonderful. I think it's wonderful. You might get monotonous few at times. I apologize. I'll try to keep it fresh with current data. But as far as the overriding and or underarching principles, it's pretty consistent. How to measure. So give me an example. I know you don't know what the margin of error is on this data, but how would it sound if you were reporting what the average number of red cards you should see is? How would it sound? You would say the average number of red cards per deck is 2.45. I'm looking for a phrase. That plus or minus, and then here's the part you don't know how to do yet. Plus or minus something. Plus or minus something, right? Plus or minus 1, plus or minus 2, plus or minus 7. Whatever the plus or minus is, it'll be plus or minus something, and that's what this course is kind of about, is figuring out that plus or minus, and then attaching it to that number that we get. But that's what you have. This is where Gallup gets it partially wrong almost every time they do a poll. 6 in 10 Americans agree. No, 6 in 10 of your sample agreed. 6 in 10 of your sample plus or minus 4%. Is that big of a deal? It might be, it might not be, but it's more correct to put the margin of error on there, because the chance of being right without the margin of error is basically 0. The chance of being right with the margin of error creeps upward of 95%. I'd rather be 95% correct than 0% correct. Hopefully you do too, right? Sometimes it doesn't matter. Sometimes it doesn't matter, but if you're making a drug for the FDA, or if you're testing a rehab procedure for a geriatric patient with muscle atrophy, you kind of want it to work, right? You don't want to be close. You want it to work, or at least with a certain level of confidence. Good! All right, let's get some light back.